Thanks very much, James. Here we are in this afternoon's session. Let me flip you over to my overhead camera. We'll crack on. Right. Pop some light on. I think we're okay there again, aren't we? Right. So a quick recap. Scratch-built loco, scratch-built chassis. And this morning we put the axle boxes in using the coupling rods, sorry, as a jig to make sure that we located the axle boxes in the right place. And since you've been away, as well as eating copious amount of cake and drinking loads of coffee, I've also cleaned up the soldering around here that we did this morning around the axle boxes. That's all been cleaned up. And if you look here, you'll see that the wheels now have balance weights on them, and I cut those out in the interval, and I have araldited them onto the wheels, and I think the araldite has set and we're ready to go. So this is the kind of crucial bit where we fit the wheels into the chassis, and we hope that the rods turn without binding. So place your bets. Right, so chassis. Now, obviously, we've got balance weights on these wheels, so these wheels have become the front driving wheels. So we'll feed the axle into the axle boxes, like so. Another thing that I did while you were away was I just ran a reamer through the axle boxes, like so, just to open them out so that the axles are a really nice fit. No slot, just a nice sort of engineering rotating fit. I'll put the wheels on. Now, if anybody knows what lead Lancashire and Yorkshire engines have on the wheels, now's your chance to tell me. Otherwise, I'm going to set them at right-hand lead, because that's what most locos are. So that would be the crank pin on the right-hand wheel leading the left-hand wheel. So this one is forward and this one is up. I think that's correct. Well, it would be if it hadn't fallen off. So we'll just fix this wheel in place, like so. Like that. And then we'll do the same with back wheel. I prepared this wheel off camera as well. You saw this morning how I cleaned up the Slater's wheels as they come out of the packets. Just polish the axle a little bit and polish the tyres on the wheels. And pop the crank pin screws in, and made sure that they were perpendicular to the face of the wheel. So that's both sets of wheels in, and both rotate nice and freely with virtually no end float. So let's put the rods on and see what happens. Nuts and washers off that Slater's kindly provide. I quite like replacing those with the cast CPL or Laurie Griffin crank pin nuts, but you'll have to ask whether the budget runs to that. So this is the right-hand rod, the right-hand side of the loco. The wheels rotate quite nicely with that one on, so that's a good sign. We'll put the left-hand rod on, and as you can see, my chassis runs beautifully. So now what you can't see off camera is me doing a little dance around the workshop. So that worked first time. We've not had to open out any of the crank pin holes, not had to open out any of the wheel bearings. Got a nice free running chassis first time. So it's always a good idea to locate your axle boxes using the the coupling rods. So that's my top tip for the day. Now also I've just noticed that we're going to have to leave these crank pin nuts a little bit loose because the bearings that I've got aren't quite long enough for the bosses. The bosses on these Lancashire and Yorkshire wheels are a bit generous. The brass crank pin bearings just aren't quite long enough to go through them, so I think we might have to have some action later on a linisher to thin the bosses down very slightly, but we'll do that later. There's no need to do that now. So all of our attention to detail and effort this morning worked. We've got a smashing free running chassis, no tight spots, no nothing. So we'll take that with us. So that's the end of the presentation, everyone. Thank you for coming. Not really. I think the next stage now is to level the chassis and check the fit of the body, and then we'll perhaps move on to put the wheel in here for the front, whatever it is, radial truck, whatever it is. So what I'm doing now is I'm going to get a piece of plate glass, which I keep down here beside me, and this I know is completely flat. It's just a piece of looks like 8mm laminated glass that you can get from any glazer, or is it glazier? And they usually just give you a little offcut like this, but it's really flat. It's like a metal flatbed. I'm going to put a piece of track on it. I'm going to pop a lovely rolling chassis on the track, and we're going to level it using the 4 adjusted screws. So I think what we'll do to help us on our way is just weigh the chassis down with something, some piece of metal, just to stop it rocking about. I'm going to have to get my trusty rule and a screwdriver. And now I've already measured on the drawing the height from the rail head to the bottom of the foot plate, and it comes out at 27.8. So the chassis sits here. Tilt the chassis so you can see it sits here on the back of the chassis and here on the front of the chassis. So we know that the distance between the top of the chassis here and the bottom of the tyre, not the flange, the tyre, is 27.8. So this is another tedious bit of the demonstration where I kneel on the floor and do my measurements. And where are we? We're at, we're pretty close actually. That's at 20, just shy of 27, and that's about the same. So we'll give all of these screws a single turn downwards and then do another measurement, and we just keep going like that forever, I'm afraid. That's one turn, that's one turn there. Now if I was doing this with an 060 chassis, I would wind these adjusters right up for the middle 2 wheels, so the chassis wasn't sitting on the middle wheels at all, and I would level it with the outer wheels and then wind the when I got the chassis level and at the right height, wind the adjusters on the middle wheel down so that there was just a nominal amount of up and down movement. I mean, it does rock very slightly, that plane, from there to there. So we'll just do a bit of guesswork and wind that one down a tiny bit. So the top of the adjuster's just resting on the axle box, and we're just taking out that movement. Let's do another measurement. And I'm afraid this is just an iterative process that goes on until we've all gone away and watched a layout video. Another turn. I think we need another turn.
Do you ever use compensation beams on a loco like this, Nick?
Well, there's a good question. No, is the answer to that.
Okay.
Not really the answer to that, because I'm building a Sterling single at the moment, and I have used compensation beams on that because the loco only has one driven wheel, and I move the pivot point of the compensation beam much rather than it being in the middle between the two wheels that have got compensation beam on them. I move the pivot much closer to the large driving wheel, and then that has the effect of transferring more of the weight of the loco onto the middle wheel.
Yeah.
In the hope that the thing, will be able to pull a better train. But of course, the singles did have a reputation, didn't they, for skidding anyway.
That's
right. I think we're going to have to go another turn. I'm sorry about this. This isn't.
I mean, what I've found with compensation beams is that with a properly compensated engine, you do get a better spread of weight on each wheel.
Yeah.
So each wheel, you've got better adhesion potentially.
Yeah, I'd agree with that. I mean, it's not very prototypical, is it? And if you've got inside valve gear, it's also quite impractical.
Yes.
But you're right. It does work quite nicely in some circumstances. I think isn't it a 4 mil thing really? Compensate the kind of beam compensation like that.
Well, Mike Sharman, of course, did his flexi chassis, which is the concept of that is to have beams all over the place,
right?
And the axles moving around. But now I did it on a Q class loco that I built, where I was designing it to have a three-legged stool effect.
Yeah.
Fixed axle and then the other 4 on a compensation beam that flopped in the center as well. So 1 point of contact, and it's extraordinary how long a train that will pull.
Right.
Compared to a typically sprung loco. Does make quite a difference.
Well, the answer is yes. I mean, I've built quite a lot of Martin Finney engines in the past, and they all tend to be like that, don't they?
Yeah, true. The bullet it's all built in.
Yeah, and the Sterling single that I'm making, I've made usually you have a wheel then that usually have the front wheel usually rocks this way, doesn't it, from side to side?
Yeah.
With a pivot in the middle, and he usually has a bar, doesn't he, like a rod that goes above that the axle rides on in the middle.
Mm-hmm.
And with the Sterling single, I've made that part of it the front bogie, so the chassis sits on the front bogie, and of course the front bogie is able to do that.
Yeah.
And then the rear 2 wheels have got a compensation beam, and it does run really nicely.
Yeah.
But I'm having the kind of perennial problem with it that now I've built the cylinders, of course, you're really having to hack substantial bits of the cylinders away to get the thing to go around a 6-foot radius curve.
Oh yeah, because the front bogey's getting in the way.
Right, the front of the chassis now isn't far out. The back of the chassis needs to go up. a little bit, which of course will have the effect of putting the front of the chassis down. But this is just the tedious part, I'm afraid, of doing this. But the reward is you get to put the body on the top of it, don't you, and go, ooh, look at that. Although we might not be able to get to that stage today, because once I've fitted this up, you might find you have to hack bits of the body away to clear the wheels. Right, so we're on about 27.8 there. That's maybe a...
While Nick's doing this, welcome to the people who've joined recently since we started the session. If you would like to ask Nick any questions about what he's doing or what he's planning to do, then do unmute yourself and ask the question.
Right, up a little bit at the front. I'm sorry, this is going to be the most boring bit of the presentation. This is just the iterative bit that you have to go through, making the chassis level. Then after I've done that, I'm probably tempted to solder up the height adjusters so they don't move. Right, I'm happy with that. And I think I'm happy with that. I can't see it because the light's on. Yep, that's fine. That's good. That's good. Right, that's level. We're happy with that. Let's just check it doesn't tilt. It does not. Maybe a smidge here. Feel that screw's loose. There we go. Look at that. Perfect. Right, so will the body fit? Will the body fit our chassis? Yes, it will. Look at that. No, it won't. The wheels hit the angle that goes around the back of the boiler. So we'll need to grind a little bit of that away. But we'll do that later. There's a little piece of angle there. Usually on a loco between the firebox and the cab, you get a little piece of angle that goes all the way around. And on this loco, I've built it to go all the way to the bottom here. But of course, this bit's completely covered by the splasher. The splasher for the front wheel will come here. So that just needs grinding away, but we'll come to that later, because the more exciting bit is to fit the front wheels. So we have a chassis that sits quite nicely on the track and is the right height, and the wheels turn really nicely. So we're happy with that. So we'll pop these axle boxes. What I did, again in the interval, was as I did this morning with these axle boxes, I ground the cylindrical part of the bearing away to give me the right amount of end float. So we'll pop those bearings in there. And get a piece of wood from the chassis, and we'll get our Slater's wheel set and pop it in there. Put the thing on the track and see how it sits, because then we have to devise some system of making sure that the the chassis will go around a 6 foot radius curve, and B, we have some kind of springing. Now I'm happy with that. Let me see the wheels do turn quite nicely in the chassis. We've got a little bit of end float, but I suspect we may need a little bit more than that, so there might be a bit more grinding to watch. But what we need in the meantime in here is some kind of springing to push the wheels down onto the track. Now, I suppose there are various ways of doing this. We could get a piece of phosphor bronze wire that just very simply was buried on the top of the axle and pushing the axle down, and bury the phosphor bronze wire somewhere underneath the inside the chassis, inside the cylinder block area here. But if you look, what I've actually done is drilled a hole again through the top of this structure above the horn cheeks, and that'll accept a 0.8mm rod. So what we should maybe do is cut a short piece of 0.8mm rod, push it through that hole so it doesn't quite touch the top of the axle box. And then what we can do is take the axle boxes out and go and find some tiny coil springs out of my stash of coil springs and put those on the top of glue them to the brass wire so that they just push the wheel down quite nicely onto the rail as the chassis is running. And then I think when we've done that, we'll get very brave and we will get the test track out and see if it goes around a 6-foot radius curve and see how much of the wheel bearing then we need to grind away to give us enough end float on the front wheel to go around a 6-foot radius curve. So let's look in my rod stash, get out some 0.8mm rod. There's a nice piece of brass rod. And if we where we end up, that, file the burr off it, maybe a little taper as well to get us started into that hole. That's it, that's got us started. We need to snip a suitable piece off that's maybe 3mm long. That's that.
What you're planning to do, Nick, is in working out the side play that you need. You can, of course, do that on a CAD program.
You could, but I do not have such a thing. So it's all going to be done the old-fashioned empirical way.
It's remarkably little on a typical 060 chassis.
Yeah,
the center driver needs about 0.8 of a millimeter.
Well, the wheelbase on this loco is so short.
It is.
That I don't think it'll need any end float to speak of, really. There is no end float in the driving wheels because you really don't need any on an 040 engine. And we're driving this wheel with the rear driving wheel will have a motor hanging on it in due course. And it's a good idea not to have any side play on that if you can avoid it. So the motor's not moving around from side to side. And then, of course, we're going to have inside motion ultimately on this front driving wheel. And it's probably not a good idea to have very much, if any, end float on that.
Exactly.
So
what's the wheelbase, Nick?
What's what, sorry?
What's the wheelbase?
240. You mean
but
in terms of length?
Distances?
In millimeters?
Yeah, roughly.
Well, between here and here is about 55, and the wheelbase of the drivers is about 57.5, something like that.
Okay, cool, thanks.
So what I've done, if you can see there, is I've dropped a piece of brass rod through the hole there in the axle box. And what I'm going to do is I'm going to attempt to tear a piece of wet and dry and just insert that between the bottom of the brass rod and the top of the brass axle box so that the axle box can move vertically. So let's see if I can do that on camera. Let's do the lifting with this hand and the inserting with the other hand. Right. So what we've done is we've just pushed a piece of wet and dry paper on top of the axle box. And we're going to push the rod back into the hole there. So now the rod sits on the wet and dry paper. So when I pull the wet and dry paper out, there'll be a gap of the thickness of a piece of wet and dry paper, which is, I don't know, about 1/3 of a millimetre or something like that, which I think should give us enough upward motion really in the grand scheme of things. And if it doesn't, we can always take the wheels out and file a bit more off the bottom of the rod. So what we're doing now is just dabbing a bit of solder on that just to hold the rod in place. So we've done that one. So we'll whiz that out. Now we do have a little bit of vertical movement, which I'm quite pleased about. That's worked quite nicely. So if we spin this around, and I can do the one on the other side. Can you see that? I think the problem is that the bulb's shining on the glass, isn't it? So we'll reinsert our piece of wet and dry paper in there. I have to say, folks, this is making it up as I'm going along, modelling at this stage. So we'll cut ourselves another piece of brass rod. Tidy that up. I know a lot of people, I know I've seen this kind of thing done in the past where people have made sort of a little radial truck style arrangement, which probably isn't a bad idea from an engineering point of view, because of course the wheel then will rotate in this kind of direction, you know, when you're going around a curve, which is probably, you know, a little bit better than this arrangement. But it has to be said that this arrangement is how the real loco was built. This isn't a radial truck on the real loco. It is just a axle box in a a wheel in a quite a simple axle box. So we've put our front wheel in now, and it does have a tiny bit of up and down movement, which I'm very pleased about. And everything still moves quite freely. So if you bear with me a couple of seconds, I'll go and grab me bag of springs and we'll go and find something that will fit in there and try and glue it in place. As you can see, I've got a big bag here of components that are labelled up axles and bearings, and there we have a packet that's just full of various different sizes of springs. Now these I buy off Daily White again. I sound like an advert for Daily White, don't I, today? I don't know whether you can see that, but the packets that you buy off Daily White, they contain things like springs that are off buffer beams, you know, springs that are out of buffers, you know, the kind of buffers that work. And then there are the kind of springs that come with the Slater's axle boxes that push down. And I think they might be a little bit too long. I think I'm proposing that we should try these brass ones to start with, because the brass ones are not quite as, what's the word, tensiony. They're softer springs. So if we start there and decide that we need stiffer springs, then we can pop some of those in later. So I'll open this packet and grab a couple of springs out of this bag. See, like they've ever been opened, they've still got a piece of sellotape over them. So how many of these are you betting on the losing? Ping off into the furthest corners of my workshop. There's 2. I'll put these over here for when I inevitably lose one. Now, attempt to separate them without bending the springs. What I'm doing is just twisting them to, there we go, rotating them to uncoil them. Right, so we now take that out and drop a pair of springs on the top of the brass rod that we just soldered into the frames. Like that. And one like that, just knocks that one off. Try a dab of super glue to stop them wandering away. At the end of that in the super glue, and just drop that over there. There we go. That's held that in place quite nicely. The other one rolled off somewhere down here. Where are you? Later. Dab of super glue. Drop that on there. Just to hold that in place for us. And then we'll pop these. I think it's imperative if you're going to try this that the axle boxes do move up and down in the guides quite freely. And it's also important that the spring isn't coil bound. Spring just moved slightly, it didn't want to bear on the top of the axle box. Okay, so that's actually sprung quite nicely. That's worked pretty well, if I say so. So now we're in the situation where we have some springing on the front wheels, which is good. There we go. That works quite nicely. It's not coil bound. You can see the front of the chassis springing up. You don't put any weight on it. So that means that when it's running, the chassis there will be some springing on the front pair of wheels. So I suppose the next stage is to move on, get out a 6 foot radius curve and see whether our chassis goes around the 6 foot radius curve, which is pretty timely because we are 2/3 of the way through the presentation now. So we'll just pop that away. Clean all these tools out of the way and get rid of this piece of plate glass and try and fit my test track here underneath the camera. Get rid of the plate glass. And my test track's quite big, so let's see if we can orientate it on that. So you'll be able to see what we're up to. There we go. You see that? Is that okay? So this part here of the track is standard gauge, set at 6 foot radius. And here's our chassis. I'll pop it on the track over here, and we'll push it around our 6 foot radius curve. And I have to say, folks, that is going to work. I claim victory.
Just as a matter of interest, Nick and everyone else, I've drawn up a box on CAD with the dimensions that Nick gave me for the wheelbase, and that tells me that the side play required on the front axle, the small wheeled axle, should be 1.7 millimeters.
End float.
End float, yes. That's assuming that the wheels are absolutely, square to the driving wheels. The two sets of driving wheels, are completely square to the.
The wheels aren't rotating like this.
Correct.
As it goes around the curve, because that's how this loco was built originally. The wheel didn't rotate.
No. But of course, the nice thing about fine scale O is that there's quite a significant amount of sideways movement available.
Yeah.
Before your flanges touch the rail.
There is. I mean, a lot. I mean, this is on a 6 foot radius curve look, and you can still see there's oceans and oceans of. I mean, this is really just the slop between the railhead and the flange.
Yeah.
And that goes to show, doesn't it, that really you don't need very much end float on this wheel at all to make the loco go around the 6 foot radius curve.
Correct.
And that was quite an easy process. I mean, we did that in what? 15 minutes, a couple of bits of rod soldered through the top of the axle box, and a couple of pieces of, a couple of little tiny springs just to locate everything. And we're kind of home and dry there, aren't we? That's kind of done. And it was as easy as that. I'm kind of ad-libbing now because I've kind of run out of things to do. Does anybody want to ask me any questions? I kind of rushed through this because I couldn't believe that the thing would run first time, without any problems, and B, I expected that there might be some adjustments that needed to be made to the wheels to stop the to the motion, stop it binding, but that's not been the case, has it? These do kind of work it does work quite nicely, and to go back to what we did this morning, it's important to reiterate that your best chance of getting a chassis to run, in my view, is to use the rods, to use the coupling rods as a jig to locate the wheel bearings. And this is a good way of being able to do it, by using the height adjusters, because then you can fit the bearings and then you can adjust the height of the frames. If the specification was to build a chassis that was rigid without any kind of suspension, then you'd be a bit stuffed, really, wouldn't you? Because you have a hole in the chassis that locates your cylindrical bearing, your top hat bearing, and it's very difficult, to move that forward and aft if you need to get the right centers. Because with all the intention in the world, if you build a connecting rod, and the connecting rod's usually they have a joint in them, don't they, to allow them to flex and do this kind of thing, to compensate for the suspension. It's very difficult to maintain the centers. It's next to impossible to maintain the same centers as the etched holes in the frames for the bearings. And then if it's a fixed chassis, it's very difficult then. You have to elongate the holes. You have to elongate the holes so that the bearing can move slightly from side to side. And then you run a terrible risk then of losing the correct ride height, and it's actually much easier, I think, to set up a compensated chassis. I mean, it's a lot more work. Of course, it's a lot more work, but it's a lot easier. And you can see this has worked quite well. I'm quite happy with that. The chassis runs really nicely, and I'm confident if I bunged a motor and some pickups on that, it run quite nicely on that piece of 6 foot radius track. And that's the hard bit, really, isn't it? Once you've done that, the rest is just cosmetic, really. I think that's the thing to realise really about chassis building, isn't it? I suppose the thing we should do now is try and grind some of the material away there on the smoke on the firebox and see if we can get the chassis into the body, and then have a final shot of the whole thing assembled. Let's get rid of this test track. Whoa.
I do have one question, Nick.
Go on then, fire away.
That is, I use a chassis jig from Hobby Holidays.
Yeah.
Do you have any experience of using chassis jigs as opposed to the
No.
extended axles that you've shown us?
Well, if you look on YouTube, I think there's a video of me building a chassis using one of those Poppies building boxes.
Yeah.
And that works in the same way. I'll just grab the one from over here. I have to say that this was donated to me by Poppies, and they are actually quite useful. They you can see they've got holes here. You get a set of sort of dummy axles that will fit all the way across the box. And you put those, the idea is that you put the axle boxes on here and the chassis in the middle, and then level the chassis up with the top of the box. And then you put the coupling rods over the ends of these screws here. These have been machined to accept that, so they're the same diameter as a Slater's crank pin bush. So you can pop the coupling rods over the ends here, and they will fix the centers. And I think the chassis jig that people like Hobby Holidays have kind of work in the same way, but a bit more sophisticated, don't they?
That's right.
They allow you to, you can adjust, you can do this kind of adjustment with them, can't you?
That's it.
Is that right? Is that how they work?
It is, yeah, yeah.
I've never tried one. I always just use the jury axles because they just seem a lot less hassle. Is that's but that's
No, it's
just kind of the way I've always done it.
I don't know about everybody else, but watching you put that chassis together so quickly with a homemade horn blocks, and the fact that it ran first time without any bind is extremely depressing.
Well, I have to confess, I did a lot of prep in the background. I had cut all the pieces ready, but really that's all there is to it. I mean, it did take me. You have to be careful when you if you remembered back to this morning, I'd already installed these axle boxes.
Right.
And you have to take a datum measurement from the back of the chassis or somewhere to the axle center to make sure that dimension's right. But I mean, originally I just made circular holes in the frames just to accept a top hat bearing, and that would have done it, wouldn't it? But I had to rejig it because he decided that later on in the build that he wanted to upgrade it to have him working inside motion.
Yeah. It's I mean, what I've done with the latest chassis that I've built is, as you've said, put the top hat bearings in first.
Yeah.
And then fit one pair of horn blocks at a time.
Yeah.
So you're then using the holes that were the right distance apart and parallel.
Yeah.
With the top hat bearings in place, get the next horn block in place exactly at the right distance.
Yeah.
And then you can work down the list of axles, doing one at a time.
Yeah.
And that seems to work quite nicely.
Yeah. Yeah. I mean, I'm kind of I don't know whether this is right or not, but it always seems to work. That you could have a fixed axle here. It could have a top hat bearing and one compensated axle.
Yeah,
it would work in exactly the same way, wouldn't it?
Yeah.
That would be my thought. I mean, if anybody has any better ideas, I'd be happy to hear from them. This is all just empirical modelling, really. As you can see, what I'm doing here is just filing away a bit of the sort of angle iron that goes around the back of the firebox, and I'm kind of hoping if I do that, that the chassis, it's hitting the back of the tyre, you see, at the moment, and I'm hoping that if I can just whiz a bit of that off, then the chassis will fit on the body of the body will sit on the chassis, and we've kind of got a finished loco then, haven't we? No, not yet. Not yet. Still a bit more to be hacked off, I'm afraid. Let's do that. Anybody any questions? Is anybody still watching?
Yeah, we've got 14 participants altogether, Nick.
How many?
14 at the moment.
It
has been up to 17. There's a few people dropped out.
Well, we're just whizzing off a little bit of the. You can see, just to recap, when I built the boiler, I put a boiler band round there, right at the very end, a brass boiler band, and then I fixed a plate to the back of the boiler here that went on planted on the end of the boiler, and scribed a line round so that the plate was bigger than the diameter of the firebox. And it gives you then, when you solder that on, it then gives you the impression of the piece of angle iron then that goes all the way between the cab. This piece of angle here that's on there on most locos, that goes between, it fills the gap between the cab and the boiler clothing. Of course, when the loco gets hot, the thing gets bigger, doesn't it? The firebox. Yeah. So you need something to take in the expansion. Sometimes it's here. More often than not, it's here on the outside of the cab front. But sometimes it's around the inside, just around the back head as well.
Well, I guess it allows the firebox to slide in the cab.
Just allows, because the firebox, as it gets hotter, it expands, doesn't it?
Yeah.
And that just kind of fills the gap, I suppose, so the crew don't get wet or whatever.
Exactly. So sliding.
There's a question from Bob on the chat. Have you seen that?
The what? Sorry.
There's a question from Bob James on the chat.
Yeah. No, I hadn't seen it. Thanks, Richard.
What does Bob want to know?
He says, for those of us who have only a small space necessitating very tight curves, in my case 3'2" or 966 millimeters, how would you accommodate this in your loco?
What was the radius again?
3'2", so half what you had. That's extremely tight.
If I had a layout you would have to make some judicious choices about the type of loco that you were running. I think you'd be better off sticking to 040 locos or something like that. I mean, you would never get a Pacific loco to run around a 3 foot radius. I mean, you would have to. I would have to refer you there to James's piece of software. Maybe he could work out, what the end means.
Yeah, go on then. I could try that one. I mean, I think that is a very good question. How would you make this particular loco go around that kind of corner? I think there's two things.
The end flow. You're going to calculate now. The end. Hey, look at that. Now we got a rolling chassis.
Great. I think there's two things you can do. Firstly, they narrow the frames. So whereas Nick's gone for quite wide frame spacing, you would really want to have a narrower frame spacing. So decrease the frame spacing by a couple of millimeters at least, so that you've got much more side play in the wheels, in the main driving wheels. And the other thing is to then have a joggled frame where the front axle is, to give that a lot more side play.
Yeah, you can make the frames do that, can't you, at the front, to give you more movement on the
exactly.
The front here.
Now you'd have to accept the fact that your frames looking through under the boiler would look a bit strange.
Yeah.
But that would make that work. And the other thing is, do you then turn the front wheels, instead of being an axle parallel to the others, into a proper pony truck,
Yes. Yes.
which
Yeah.
would look
Yes,
like,
I mean, yes, I mean, you could also scallop the frame, couldn't you, so that the wheel passed underneath the.
Yeah.
You could scallop the frame there, so the wheel passed underneath the chassis, which we don't have in this case.
Yeah.
Well, this is it. That's it. You see, that's it, guys. You see, the thing fits now. I'm very pleased about that. Everything
Brilliant.
fits quite nicely. There's enough clearance and what have you.
Yeah.
So
very
again,
nice.
I claim victory. And what I need to do now is I need to trim the screws there that are holding the trim the screws, because they're hitting, when you rotate the wheels, they're hitting the foot plate. You see, they're bashing into the foot plate. They won't pass like that. Look, clunking right there. So we just need to shorten them, which is a fairly straightforward job. And other than that, I think we'll just file a tad more off this side, off the right hand side. Go up that with a bit more. Yeah, there's plenty more that can come off there. So we file a bit more of that on. I'm quite pleased about that. That's worked out quite well, hasn't it? Because some of that was quite heavily rehearsed and thought through. And the latter, because it went so well, the latter bit of it really was all a bit ad-libbed. And if anybody, would have done this in a different way, please tell me. It would be interesting to hear how other people might have got around the issue of controlling this axle here. Very pleased with the way that's worked out. And once we finish this session, all I really need to do now is to take the wheels out and take it downstairs and go and wash it with some bicarbonate of soda to get all of the flux off. That's what I always do at the end of a session, is always take the work that I've done in that session downstairs and just wash it in the sink with some just the kind of thing that you get from the supermarket for baking cakes, bicarbonate of soda, because of course it's a weak base and it will neutralize the weak phosphoric acid, which is a weak acid. So
Got another question here from James Hutchison. Nick,
okay.
I'm trying to build the chassis on a Finney 7 Adams radial.
Oh yeah.
It has 2 compensation beams on the main wheels.
Right.
When I get it all together, there doesn't seem to be any rotation available on those beams when they are resting on the square horn blocks.
Right.
Guessing I need to remove some material from the compensation beams, but how much up, down, and rotation movement is needed in those beams?
Well, compensation beams don't work like that, do they? They always rest on the top of the axle box.
Uh-huh.
There should never be a gap between the compensation beam and the axle box. It rides on it. So if you read it, I think if you read the Marty Finney instructions, he suggests that if the loco's not sitting at the right height, then you have to take a little bit off one of the surfaces that bears on the top of an axle box and take the same amount off the one on the opposite side as well. Does that make sense? Let me see if I can draw you a picture.
Yes, I think I'm not
So
100%
you've got
sure.
an axle box like so, haven't you? And an axle box like so. And then you've got a beam that basically does this. And it sits on the top of the axle box there, and it's pivoted in the middle, isn't it? Like that. And you've got the same on the other side. And when that one does that, that does that, doesn't it? That's the idea. And this is your kind of ride height adjustment there, isn't it? That's the if you want this dimension to be lower, then you need to file a bit of material off here. If you want it to be taller, I mean, ideally you'd file a little bit off both, but filing it off one side does have the same effect. If you want it to be the axle boxes to go down in the frames, i.e. to raise the whole body, then you need to add material to this. And what I would do is just get a bit of solder on the tip of your soldering iron and just dab it onto the surface here, and then file it, like I did earlier, until you get the right ride height. But when you've adjusted this, you also then have to make a similar adjustment, because the front axle, drawn it a bit big there, sits on a rod, doesn't it, that goes from side to side in the chassis. Is that how the Adams radial works? Perhaps unmute himself.
Can you hear me? So the problem I've got is, Nick, where you've got that rotational where one goes up and one goes down, I haven't got any movement at all. It's just like locked solid into
they won't move.
Yeah, they're in the horn guide. You cut like a piece out of the guides that the horn blocks sit in, and it's just the exact height. I've followed all the directions to where the which markings are and so on, but there's no rotation. So I figured I might have to take some material off both sides, like you say, to create.
I mean, you could trim a bit off the top of the axle box.
It sounds as it is the compensation beam hitting the horn block, James.
Yeah, so they rest on the top of the square blocks, but also you had to cut out like a guide through the guides that the horn blocks sit in.
Yeah.
And
yes,
like they're resting on
here, like that.
I think
so
you
maybe
can
take more out or something.
Yeah, more out of the horn block side, just on the two inner parts.
Yeah, you need to make sure that the beam can do this.
Yes.
Okay.
Some more out of the horn block. The horn block doesn't actually need, or the side of the horn block doesn't need to be any higher up than the middle of the axle when you think about it.
Okay. Yeah.
So you can cut a lot out of it.
Yeah,
okay. That's wonderful.
Even if you cut too much out, you can still add material afterwards, can't you?
Yeah.
It's not a complete disaster if you overdo it.
Yeah.
I mean, obviously, the best engineering practice is to take it equally off both sides. But it doesn't matter if you just take it off one side. It just means the beam tilts, doesn't it, at its sort of midpoint.
Yeah, which again won't matter. No, I think you need to take a bit out the horn block, James, by the sounds of things.
Here and
okay,
here.
super.
You need to get to the situation where this rotates.
And how much, Nick, do you want rotation-wise to?
Next to nothing. Next to nothing.
Yeah.
Tiny bits. I mean, if your axle box is having to do this, then you need to go and look at your track work, really, don't you?
Okay.
No, a millimetre or less.
Yeah, I would agree with James. Fractions in movement, because if it's having to go miles, then the problem's something else, isn't it? It's your track.
Yeah.
You can only compensate so much for poorly laid track, can't you? And
wonderful. Thank you very much.
I hope that helped.
Question from Andy Best. Hello, Nick. Did you fabricate the axle boxes, or are they commercial items?
Well, the axle boxes are just the Slater's ones. Yeah. They're just the square Slater's ones. They come in axle in horn guide sets. But if you ring Slater's, they will sell you the brass axle box separately, and they're only about £1 each. They're very cheap. So it just makes more sense, doesn't it, just to buy them? I think. I don't know what you think about that.
Yeah, that's great. Thanks, Nick.
Yeah.
I think we're there, aren't we?
Yeah, it's 2:15.
Quarter past two. Somebody else will want this feed now, won't they?
Not immediately, fortunately. But I think we've come to the end of Nick's presentation anyway, and I would like to thank him very much indeed for his advice.
And we did do it, didn't we? We did get a working chassis. I'm very pleased about that, Sealer.
We have. Brilliant.
It works. Well, it kind of needs a bit of finessing. These screws need the ends chopping off them because they're hitting the frame, hitting the foot plates.
You'll have to start another one for your next demo, Nick.
No, we're going to carry on with this one. We're going to see this one through to the bitter end.
Brilliant. So, thank you very much, everybody, for attending.
Thanks for coming, everyone. Hope it wasn't too dull.
And thank you, Nick, again for the presentation. And I hope you enjoy the rest of the show for the rest of the day.
Yeah, enjoy it. See you
Thanks,
later,
Nick.
everyone.
Bye-bye now. Thanks.
Bye.